I hope you are interested in what I have to present. And actually, that's a long dream now in a third version. There's a type of what you know from simulation software that I thought a long time about how to develop and software to help a compounder to be faster and in his development to save some, beside the time, also some cost. So what I'm doing now, I'm giving a small introduction about the idea, then the justification, how we calculate and what we do. And then I do some sort of experimentation to confirm that those type of thoughts are really helping out in practice. And we draw a conclusion. And you need to know, to understand what I'm then presenting is that it's all born in a manufacturing environment and not in a laboratory or something environment like that. So first of all, when we already had started our development, I investigated patent literature, and you see here a nice patent from a well-known company in the year 1904 and later in 2002, where obviously brilliant people in the industry thought a similar way and tried to go a similar way. In this case, they deal a lot with neuronal network mass, and the disadvantage we will discuss later in a couple of sentences of neuronal network. You need massive data actually to feed that, which is really a disadvantage. And then you see a couple of other companies trying to solve their problem by helping simulation, by get help from simulation. So what we're actually doing when we do this experimental design, we're doing correlation, and we describe this correlation in mathematical terms, what we call regression equation. The disadvantage of this is that you have an organized database which you create during these trials, which is then limited to what you do and what you try to figure out. So it depends on the factors, and that is the limit, so you have a very close set of data. Obviously, that is very helpful in development. When you have something unknown, then it is a tool to at least explore this unknown problem, because you have no history. Why it is very different when you are in manufacturing and you want just to create or adjust something that you should be able to use your database. So that the question is why I did that. Every company has a history of compounds. And you see in my last position, we had around 40,000 data sets in our files, in our computers. And that represents a history of 20 years, 25 years. Yeah? And this is a lot of money actually spent for this, and we don't use it anymore. So what I wanted to do is utilization of this historic compound database, then minimizes efforts and time in development, that I can play around by simulation and then do some sort of minimized experiments, that's confirmation experiments of what I could calculate, and I wanted to be playful with my database. So the creativity portion of my brain should be used. those data I cannot describe with any algorithm because I can make only statistics of that, and I have no algorithm like the regression equation you have seen. So that gives me already a start, a compound, and which I then used in a type of DOE to explore the surrounding of this compound idea. So, and again, we have still methods in compounding. One of the preferred methods is still trial and error. And I wanted to avoid trial and error by this way, because trial and error is really not a method to go. Okay, what I do now here, you give you a short impression of how much money we are talking about. In European environment, you can say every recipe you write on a piece of paper, test and actually manufacture and then test is a value of around 500 euro. Yes, and when you add up, multiply now 500 euro with 40,000, you know we are talking about a couple of 10 million already spent. Yes, and that should represent also some knowledge. And then you see all this question arising why we cannot really take that as a working capital and not as an capital which is gone. We want to avoid reinvention, that is, and of course increase the knowledge, but first avoid multiplication, doing the same thing again and again. So what we do now, we have a database created with statistic experimental design. We have a database created with which is organized, limited in size. I already said that. And then we are able now to use with this tool unorganized and unlimited databases like this 40,000 data we have. And I want to have the ability to predict something. And if the majority of factors relations are linear, yes, I can use a simple math like first order regression actually to use that in this compound, and then I know by my own experiments that we are in a 95% confidence interval in our prediction compared to the confirmation experiment. So I give you an example here of a specification as a J200 system, which is a most closed system in a spec and widely used in North America and in Europe as well, and I believe also in Asia. And when you go in the old compounding charts, yes, and try to follow that, you see here a linear response surface lines, which are telling you, first of all, that the relation of carbon black and oil in this case has a linear relation to most of the properties, if not all of the properties. So that means first order regression may be justified even by that. If you go now further down and investigate almost all the properties you can measure on this compound, this chart represents here a type of, let me say, compounding window for this compound. And you see here in real that almost all properties you can measure are having a linear relationship to the ingredients. That makes it very uncomfortable for us to build a software for ourselves because we can go with first order. So what we do now with this software is nothing else, which you see is a little bit a similarity of picture, which you already see with a hidden mass of neuronal network mass. We have a compound database, then we cross-blend in a first iteration, second iteration, 100th iteration, and then the outcome is at least one recipe, not 4 in this case. That was a little bit misleading. At least one recipe as soon as my distance between my result and the prediction is the smallest. That is a sentence I have to say, because very often you have conflicting targets. Yes, for example, elongation should be high and hardness should be high. That is mostly a conflict, because elongation falls short, and then you have to have a tool which you weigh and do a trade-off. We will see that later on. So what we're actually doing, we're starting somewhere and getting somewhere where we see a solution in this, what we call multiple iteration. And then you can actually analyze the compound which is written down in the prediction. And what we already can say, that this works with smaller and larger databases. We are not limited here with this tool. And now what I try to show here is I made a very simple, first of all, with an NR filler DOE, which is explained here with a schematic of a DOE. So here I have 11 compounds, and I made a prediction with the tool that you have a regression line here and your measurement and measurement errors. That is a Gaussian distribution of the measurement points around that line. You see your accuracy of the measurements. You see your Mooney viscosity and T5 at different temperatures. So we are significant, and now I try to predict this with this set of data with the tool, and then you see that is the optimization calculation from the statistic experimental time, the software, and here you see that is the unsmoothed data actually from the compounding software and the values there, and you see that it's very close. Actually, that's all inside the measurement error. So the next example is a larger trial given by DuPont in the past on the effect of some accelerators and on EPDM with a different ENB. And there's also a tensile and elongation significance. Even you see that it's more cloudy now, so measurement error is much higher. Prediction lacks of a precision. But when you go again in the optimization from both sides, you see here that this is a prediction area from the statistic experimental design software, and this is a software result, which is actually one compound, and using unsmooth data again from the compounder software. And when you really see that as an experienced compounder, you will again say it is inside the measurement error. So we are so far fine with that. So I ask myself, and how I can even have more proof of that. So I used an historic database from Standard Malaysian Rubber, by the way, which was one of the most complete data sets in the booklet, and tried to mimic an experimental design out of this database using the software. And you see here that you have hardness and a simulation of the hardness. Yeah, so this is using the historic database and actually using the similar database with the hardness simulation. And actually, I try to confirm this data with an experiment with the help of the Mahidol University here in Bangkok to get that also a real fresh experimentation to use that in comparison to this type of simulation. And when you see the tensile break, and you look here in the edges, you see that the data are pretty close. Even the measurement error on tensile is a little bit larger than all the other measurements. So if you see that really there is a type of onset, yes, and that is obviously because the old database used their standard Malaysian rubber, and the people here replacing that by standard Thai rubber. So, and obviously they use also a different machine. Yes, I think that the standard Malaysian historically used the tangential mixer, and the Maidol University, they have an intermeshing, so you have a different molecular weight as an outcome, actually. So you understand also in detail the onset, specifically when you see here elongation at break. So we are fine with that. And now you see here a screenshot of the version 2.04. You see here a cell with name, recipe, and ingredients and properties. These are an identifier for the software if you import a data set from Excel, for example, or a table calculation program. And then you see here the spread of your data, so you can analyze if there's any lack of data in your database, and then you could put any target from 2 in, either on ingredient or on properties. And then when you make the run, yes, you get one compound, and you see also the compounds used to create this one. And this is a data set here for training, is implemented in the software, which is 10 or 15 data. So what we did now in the version 3.2.1, which I publicize with this talk, that is first of all that you see a similar screen, but you see here that we first of all calculate the total sum of that, and with that you can now go and do actually the same as before. So the addition to that is now that we put some tools, some analysis in. For example, if you see here the carbon black, and now you see the distribution of the recipes, how much carbon black is, so that you can control whether this is even or not. So how much or how good data is your database when you go in then to calculate something. That is one thing. And then the other thing is, of course, that you have high pressure on costs on any compounder. And he wants to know a calculated density. So we put now a tool in calculation a density. And at the same time, you can use this for cost calculation of the compound. And if you want to merge different data sets from different files, for example, you can do that by coding the ingredients and the properties. And first of all, with the help of the density and cost of the ingredients, you can now calculate the density of the compound. You can calculate the cost per liter and the cost per kg. And even now, in addition to what I said before, you can now put a cost target here in. So that should help the compounder to find really the optimum solution, because I said yesterday in my talk that in extrusion, for example, you have around 70% material cost on total. So 30% is everything else and 70% is material, and that gives us a reason for the importance of the material development to control their cost. So, and then when you do that, so you have here a button for merge different files. that they are very nice organized that we use to see them. So what we have a creation of formula according to predefined criteria, either ingredients, properties, or cost. We have a traceability back. Why we failed with the neuronal network mass, because neuronal network mass is very intolerant to mistakes in the database. So we need to actually be able to track back that we can identify values by typing error or so in the database. And that was one of the specifications for this program. And if I'm going that way, then I can have an integration of this with the statistic experimental design approach, which I still need for development. So I have then a database with blocks out of the statistic experimental design. And even if I can analyze databases of different origin with that way. And what I always stress in any of my seminars is computer is computer. Yes, we tend to believe computers, and what we see on the screen, we must confirm that by experimentation. That is really a thing which I cannot, I should stress, like safety repeats in an airplane. Yes, you must confirm, you must confirm. Okay. What I saw in my projects, yes, that you at least are in a 95% confidence interval, which is very close to measurement error, actually. Okay, the sample should show that formulas can calculate it, because thanks to whatever, we have a straightforward relationship between properties and ingredients. We have very little differences to the experimental design, if any, very little differences to DOE software, so we can mingle that ideas. I'm still a large fan of statistic experimental design. We have formulas which scores in a 95% interval. And of course, I need to do my confirmation. So, and then I have a starting formula calculated, which can guide me to a first or center point formula in a DOE software. And I think this is the most powerful approach to save at least cost. And I saw in some cases also to save the company. Yes, specifically when you rely on 70% of total cost. Yes, you know that this is a very important thing, specifically when we have a price increase in raw material. So I thank you for this presentation. I will then do all my update in my website to give you a price and more information on my website then. With that, I haven't done that so far, yes, because I'm now here and not at home. But this is my official start for the version 3.2.1. Okay, thank you for joining, and if you have any comment, you can find me here and tomorrow after the seminar. Thank you very much.